So today's topic is on Dasein Cloud. It's pronounced Dasein, and there isn't anybody who ever gets it right. It's actually a term from German philosophy, so it's a German word. And we'll talk about how to use Dasein Cloud to essentially write an application once and have it work against any cloud that operates out there. A little background on myself before we get going. I go back with open source stuff about 20 years before there was a term open source, doing games and that sort of stuff and releasing the software for free. In my particular areas of expertise is Java, MySQL, and cloud computing, and as we get into some of the aspects of Dasein, you'll see how especially my work with JDBC has influenced the direction that Dasein Cloud has gone. If you want to get a hold of me, I'm very open with accepting email, george.reese@instratus.com, and you can find me on Twitter with the George Reese, very simple to remember. My most recent book is Cloud Application Architectures. It's a book on how you make the move into the cloud and approach moving applications or building applications that are going to run in the cloud and run against any cloud. So today's topic is Dasein Cloud. Dasein is actually, I mentioned that I've been doing open source for almost 20 years now, and Dasein is essentially the moniker that I've released all the open source stuff that I've done. And basically along the way, wherever I've been, I've always developed a bunch of libraries that are just sort of general use to everybody and not specific necessarily to the business I'm with. And so those have been, ultimately released under this Dasein name. They include a bunch of Java utilities, a Java persistence library. If any of you have read my Java database best practices book, and to a lesser degree the JDBC and Java book, the beginnings of that Java persistence library show up in that book, actually. MSQL JDBC is another one, not very highly used because MSQL isn't used by pretty much anyone anymore. It was actually a popular open source database prior to MySQL that was popular around 1995. When JDBC came out, I wrote a driver for it, and that's what that is. Dasein Cloud is a set of libraries that provide cloud abstraction. And all of these tools are released under the Apache 2.0 license, and you can get them at dasein.org. They are not Apache projects, though. They're just under the Apache license. So the problem I'm trying to solve with Dasein Cloud is this idea that as cloud computing has evolved, each cloud has come up with its own way of modeling the problem of cloud computing, and I've picked a particular subset, in particular the server-image relationship to sort of illustrate this difference. On the left-hand side, you've got Rackspace way of modeling things. So, you got a server has an image, and it has a basic set of information about it, including a list of public and private addresses. Amazon, on the other hand, the server object has almost no metadata associated with it. On the other hand, it, like Rackspace, does always map to a machine image, and the machine image has a lot of metadata associated with it. And then you go to GoGrid. Oh, and by the way, the AWS server doesn't really have any IP address information associated with it. That's an entirely different model area within AWS. And the only way you can sort of get at the public IP address is through the DNS name. Then you go to GoGrid, and GoGrid has IP addresses really as first-class objects that get mapped on a one-to-many basis to your server. The server has a set of reasonable metadata, and then again it's mapped to an image. And one thing that I've left out here is you can even go to an API like the vCloud API, which actually the relationship between server and image is optional. So that presents obviously a huge challenge to anybody who's going to write an application that has to talk to the APIs along these various models. The other problem is that, you know, in addition to modeling the problem domain differently, each cloud also has a different API for interacting with that model. So you've got you know, the Rackspace API, you got GoGrid's API, you got Amazon, you've got Cloud.coms, you got vCloud, and any number of other APIs out there. And they have different models for authentication. Rackspace, you authenticate before making the call, and GoGrid and Amazon, you sign the request, and then the result may be returned in different formats. Both Rackspace and GoGrid do both XML or JSON based on what you pass in, whereas Amazon does only XML as a format. Then they also, when you get into the Java world, there are many tools for talking to each of these APIs, and I've essentially reverse layered the tools for AWS and Java here. At the most basic, you've got Typica, which really is a direct translation of the Amazon EC2 API into the Java programming language. So there's an object in Typica for every AWS EC2 action, and then there are data types that map directly to the results that come back from the EC2 API calls. JClouds provides a layer of abstraction that does get you a layer of cloud independence. So whereas Typica is directly an EC2 or AWS programming API, JClouds is an abstraction that I call it a sort of a network abstraction for Java. And this is a little bit hard to describe, but essentially it takes away all of the hard stuff about things like authentication and network communication and transport format, and models the problem in a somewhat abstracted format for your applications, but then provides objects that map to the domain model of each of the particular clouds. So it's very much a good tool for interacting with each of the detailed features in the way a given underlying cloud maps or models its own cloud in a way that you don't have to worry about the differences among things like authentication and network protocols and so on. Dasein Cloud is a level of abstraction even above and beyond that, and the most base way I describe it is JDBC for the cloud. It is a complete independent modeling of the problem of cloud computing in the Java programming language, and then mapping that problem into the different cloud models and APIs. In a lot of cases, Dasein Cloud talks to JClouds for the interaction with the underlying cloud. You could, in theory, see a scenario for Amazon where you had Dasein Cloud talking to JClouds, talking to Typica, talking to the underlying Amazon EC2 API, but that doesn't, in practice, we don't do that. Dasein actually talks directly to all three talk directly directly to EC2 because of a variety of practical reasons. When I say JDBC for the cloud, you know, JDBC, depending on where you come from, seems like a bad thing for certain people, but I mean it in the sense of what JDBC has right. And what JDBC has right is it truly is an independent API that allows you to write once and talk to any database out there and leverage the full capabilities of each underlying database in a write once, run against any database fashion. The only limitation on that is if you embed SQL into your JDBC that is specific to an underlying database engine. Fortunately, in the cloud space, there's no analogy that we have to deal with in terms of abstraction that is analogous to SQL, so we don't run into that particular caveat that JDBC runs into. So this is a Dasein approach. An application will talk to an abstraction called a server that has a rich set of metadata that then under the covers maps to any one of the different supported clouds concepts of servers. So in the case of vCloud, it's mapping to a vApp object, to vSphere, it's mapping to a virtual machine node. The other public clouds, it's mapping to their various server or VM objects. And then where the underlying cloud doesn't directly model a particular piece of metadata, the Dasein Cloud implementation tries to glean that from context or other bits of information. And you'll see when I get in a few seconds how Dasein Cloud sometimes you know, handles situations where an underlying cloud provider doesn't provide certain data. Now, if you're familiar with JDBC, you can start to potentially see how the similarities are. Basically, there's this abstract concept of a server that you at the application layer are working with, and then for each cloud provider, there's what we call an implementation. But you know, that's analogous to a JDBC driver as such. So there's a bootstrapping class I'll talk about in a second that then provides you with a server object that your application talks to, but that server object is populated and backed ultimately by a model object from the underlying cloud provider itself. So here's an example piece of application code. It goes, and I've, you know, assumed the magic of getting a provider object has been dealt with here. So right now, forget how we got this provider object, but once we get a cloud provider object, we ask it for its server services. Server services is the gateway into any into the modeling of servers in a particular cloud. If it doesn't have server services, that means that it doesn't support virtual machines in that cloud. So for example, in the Google Storage Cloud or the current shape of the AT&T Synaptic Storage Cloud, they don't have VM compute services, so those providers return null. For EC2 or Rackspace or GoGrid or ReliaCloud or Cloud Central or anybody else who does the virtual machine-based compute services, it will return a services object. And then you can go in and call the list method to list all of those out, or any of the other methods to do things like terminate a server or whatever. In this case, this simple application just lists them all out and terminates. I'll talk a little bit about error handling later, but in short, there are two kinds of exceptions that get thrown by Dasein Cloud, and depending on different error conditions that occur. So I'm going to drop to the command line real quick and show this in practice. Now, hopefully this is big enough for everybody to see and isn't too tiny. I'll start with listing servers in the Amazon cloud in a particular account. So this particular command line is a tool that actually is part of the Dasein Cloud repository that is a simple application that provides command line interaction with Dasein Cloud. So in this case, I executed the command, pointed it at AWS and this dcl.cfg, which has things like our the name of the implementation of Dasein Cloud and all of my authentication information. Because it has all the authentication information, I will decline to show it to you as part of this presentation, but it is out there. An example one is out there in the repository that you can review. The -s says that I want to execute an operation against the server services in the Amazon cloud, and -o means that I want to list those servers. So then it goes through and lists the various servers and the state they're in, and all the basic metadata around it. Do the same thing over in the Rackspace cloud as well, and what you'll notice is that here I've got a different configuration. That's the only thing that's different in this particular instance. And then the metadata that comes back may be in a slightly different format. So you'll notice Rackspace gives you numeric IDs, Amazon gives you the string IDs. The DNS address isn't populated, and that's what this particular field is outputting, is the DNS address. The Rackspace cloud has real server names as part of its metadata. In the Amazon cloud, there isn't a name attribute as part of the metadata, so the Amazon implementation uses the ID as the name. In Rackspace, we don't get the launch date as part of the metadata, so it's coming back as the beginning of the Unix epoch. And then in both of these particular clouds, there isn't an API or a metadata set for things like platforms, so Dasein Cloud tries to guess at it. But you can see here, again, this is a single command out there that is providing that is written once and just based on a configuration file, going out to multiple clouds and listing the different servers out there. Obviously, listing servers is a simple example, but this general metaphor of interacting with Dasein Cloud applies. Before I get going back into the presentation here, do we have any questions so far, or should I keep going?
No questions so far, George, so
okay.
Go ahead.
All right.
Thanks.
So I promised to get into the architecture a little bit earlier, though I did a little bit of teasing. There is this cloud provider object that is sort of your bootstrapper. It is similar in concept to a data source in JDBC. It provides you access to all of the different services that Dasein Cloud supports. So in this particular modeling example, if I were to write an implementation of Cloud Provider, and Cloud Provider is an abstract class within Dasein Cloud that specifies that if each cloud has to implement, for example, a get data center services method. And so in my AWS class, I have a method called getDataCenterServices that overrides that interface and returns a concrete implementation of the data center services interface. And data center services is a Dasein Cloud interface that prescribes those 6 methods that are in the diagram there. And regions and zones is actually a concrete implementation of data center services for the Amazon cloud. And so when I query in my application, get data center services, and operate against a data center services interface, what I'm really getting under the covers is this regions and zones object that takes care of modeling the Amazon cloud for me. The simplest way to get a cloud provider reference is with Jindy. So I can, create initial context, look up that cloud provider in my Jindy directory, and then begin interacting with it. Practically speaking, if you're playing around with Dasein Cloud, you're probably not going to have a Jindy directory service lying around, so you're probably going to want to do things the hard way. So here's an example of complex bootstrapping by hand. So this is a simple class that takes in all of the configuration information as arguments rather than going to Jindy. So the first argument is the implementation class, and the first thing I do in the method is get a cloud provider by calling class.forName on the implementation class and get a concrete reference to whatever happens to be the implementation I'm going to work against. Then Dasein Cloud has an object called provider context, which you can pass in to establish the context in which it's operating. So set endpoint is an operation so that you can tell it which endpoint, the API endpoint to operate against. Account number is things like your AWS account number, whatever uniquely identifies your account in the public cloud. Region, obviously being the region that you want to work with by default. Set access keys are typically the API keys on top of everything else that a cloud provider will give you. Some clouds don't provide you API keys. They expect you to log in with your account name and password, so you pass those in for set access keys. And then you connect and do whatever you want with that connection. When you're done, you close the connection out. Probably important to note here is that this provider.close method isn't strictly necessary. So you obviously should be in the habit of closing out your JDBC connections and other resources with a lot of other APIs. Here, close is more of a security measure than a resource measure because we have the access keys in memory within Dasein Cloud's memory space. Dasein Cloud has it in its memory space only as byte arrays, and what provider.close will do is to wipe that memory so that Dasein Cloud's no longer holding on to, and it securely wipes that memory so that Dasein Cloud is no longer keeping that around. So it isn't actually closing out any sort of network connections or anything like that. So if you once you got your provider and you want to know what the underlying cloud provider supports, you ask it first and foremost for the various services you want. We've already seen that with server services. Here's another example with CDN-based services. So in this case, very simple logic. If there are no services, we do whatever logic is centered around not having a CDN, and if it does, then we interact with the CDN services. On a more nuanced level, so obviously the do I support CDNs or do I support servers is a rather simple scenario. There are more complex scenario or situations where a cloud does load balancing one way, for example, but yet another does it a completely different way. So here is an example of handling that with load balancers. Some load balancers, when you allocate a load balancer, or some clouds, when you allocate a load balancer, that load balancer has either a DNS name or a public IP address pre-associated with it. In other clouds, you actually say, I want a load balancer with this address, and you specify the address yourself. So here's an example of Dasein Cloud providing you access to metadata about how the underlying cloud provider handles the address management with respect to load balancers. We start out with a null address ID, and then if this underlying cloud provider doesn't support addresses, we go get one ourselves. And the grayed out stuff here means it represents logic that you're ostensibly doing somewhere else. Obviously, the allocate address is going to go out to your actually use the address services in Dasein Cloud, allocate an address, and then return you back your address ID. Then you can go to your load balancer services and create a load balancer that has that address ID if the underlying cloud provider doesn't assign them. And obviously, if it does assign them, then you're passing in a null address ID and you're relying on the underlying cloud provider to deal with that issue. So I'll show a little bit more of a complex example here. So we got back to the, actually I want to bring up the load balancer test suite. So here is, within Dasein Cloud, we have a bunch of test suites, and I don't think I have a way to make this bigger, unfortunately. Essentially, these test suites run through the logic, and as you can see, it's in the Dasein Cloud package, so it's completely cloud independent, and it goes and sets up the test, runs a test using Dasein Cloud logic. So wanted to run through very quickly some more complex stuff than the simple server listings we've seen in place. So the first thing it does is it goes to the data center services and lists regions. Data center services is the only service that all Dasein Cloud implementations are required to have. So data center services will actually never return null, so I don't have a check in here for null in this case. Before running the test, however, I do have a check for if the load balancer services are null, and then the test suite doesn't execute if the underlying cloud provider doesn't support load balancing. Then I establish a context for interacting with the load balancer services, and run my initial setup for making that test suite execute. And then, and part of that is setting up an address that I'm going to use for my data center services, or my load balancer services. And here you can see that that test that we've already executed. So in this, if the setup is supposed to go get me an address if the underlying cloud provider doesn't assign assign addresses to load balancers. So this logic here is checking to see if the cloud doesn't assign addresses and I have an empty address, then the test has failed setup. Then the next thing is to go and get the algorithms that are supported from the load balancers in the underlying cloud. And this is as far as I'll go into this, but it illustrates how we can handle the differences. So let's say you're building a tool that lets people select what algorithms they're going to create load balancers with. Well, you can query Dasein Cloud to get the full list of load balancing algorithms that are supported with the underlying cloud. And so here we go to the provider. We've already cleared that it supports load balancing before we got to this point. and we ask it for the supported algorithms. In the test suite, it just happens to display all of the algorithms, and it also provides a default algorithm because the rest of the tests in the test suite then go on to leverage the default algorithm that it picks up. All clouds are expected to support round robin by this test suite, and that is sort of how Dasein Cloud's test suite goes ahead and makes sure that when it gets later in the tests, it's not using an algorithm that's specific to that particular cloud provider. So I'll go back into the presentation part here. And probably, before I go a little bit further here, are there any questions that we have at this point?
Yes, we do have one question. It says, it's from Roslyn, who's saying, so you're taking the functionality that a cloud would normally do, like load balancing, and putting it in Dasein to enable use of multiple clouds? I think it's just for clarity here.
Well, so we're not doing load balancing. We are, an intermediary between your application, which is going and asking for a load balancer, and the underlying cloud. So you ask Dasein Cloud for a load balancer, and then Dasein Cloud turns around and translates it into the particular request for the cloud that you want to work with, and then request that load balancer resources from Rackspace or Amazon or whatever you might be using. But Dasein itself isn't doing that, if I understood the question correctly.
Okay, that makes sense. Does that answer your question, Roslyn? Okay, great. Thank you, George. That's it for now. So go ahead.
Okay. So again, the objective is to provide the write once. If you remember back to the grand old marketing days of Java, write once, run anywhere. The objective of Dasein Cloud is really to enable you to write an application that uses cloud resources a single time, and then no matter what cloud you're operating against, not have to recompile or rewrite that application to have it just work. It does assume that any services you're depending on are available in the target cloud, but that's a different problem to solve. So it's this idea of write a cloud application once, and then it'll work against any cloud. So I should have mentioned earlier. So there are two core sponsors of Dasein Cloud, and Stratus is the company I'm CTO of that does cloud infrastructure management. It obviously, since I work for it, is technically sponsors Dasein Cloud, and also JClouds, the API I mentioned there. They're a huge contributor to Dasein Cloud as well, and there are other contributors beyond people in those two organizations or groups, but those are the primary contributors. So here we're actually looking at an Stratus user interface window that's listing IP addresses, and what I'm trying to show here is, from a practical perspective, how this abstraction that we've been talking about in Dasein gets translated into an application like Stratus. So within the Stratus user interface, we're looking at a console that's viewing Amazon Web Services here, and I've clicked, first off, my little actions menu, when I click on a particular address, gives me two options, assign and delete, and that is reflective of the capabilities of the underlying Amazon cloud. And then when I get my little dialog box that allows me to assign it, I pick whichever server I want and assign that server. If I go into Google, I see
Oh, sorry, I thought I had unmuted. Looks like we've lost George for a second, so I think he's in the process of joining the meeting again. Let me see if I can get him. George, are you still with us? George, we've lost your audio. Okay, we'll watch him go through this. And thanks, everyone. This happens occasionally, so. We'll see if we can get. Oh, I know you're here, George. We're just waiting for you to come back to us, and don't forget to depress your talk button.
Can you hear me now?
There you go.
Okay.
We can hear you now.
It's interesting that it calls me George too. On the screen there.
It always does that. Yeah, it does that if you log in more than once. So carry on.
Must have relogged me in or something. Okay, so let's see here. So are you still seeing my screen okay?
Yes, looks great.
Okay, all right. So within the user interface here, Enstratus is asking Dasein Cloud, does this cloud provider, and the important thing is Enstratus doesn't know that it's Google, it just knows that it's talking to Dasein Cloud and asking this Dasein Cloud if Google supports IP address allocation. The implementation of Dasein Cloud for Google says no, and so Enstratus shows a window that says feature not supported. Then, if we go into Relia Cloud, we get yet a different user interface presentation. And this, in the Relia Cloud scenario, you allocate IP addresses, but you don't assign them to servers. You treat it more like a traditional firewall type scenario where you're forwarding on addresses to traffic to different ports on different addresses to different servers. So Enstratus queries Dasein Cloud about different features of the cloud provider it's currently working with, and in this case we don't have a forward or don't have an assign action, we have a forward action, and when I click on forward, what I get is this dialog, which is obviously very different than the Amazon dialog, which was just about assigning it to the server. You know, from a programming perspective of building a Java application, you know, from the Enstratus perspective, Enstratus doesn't know that I'm dealing with Google and Relia Cloud and Amazon or anybody else. It knows that I've got clouds that do forwarding, I know I've got clouds that do assigning, and it's just asking, is this particular cloud I'm working with right now a cloud that does forwarding, or is it a cloud that does assigning? You know, so that's the compute side of things. Then Dasein has a storage part of things that, you know, follows the same model. And, you know, I talked about Google not supporting server and not supporting IPs. It's not that they're deficient cloud, it's a deficient cloud, it's that it's a storage cloud. And so what you see up here are the different storage clouds that Dasein Cloud supports, and our storage services API. The way storage services works, and I apologize, I tried to avoid a bunch of bullet point slides, but I couldn't get away with it here, get away from it here, is that Dasein Cloud actually models a storage hierarchy. So you don't need to know when you're writing to Dasein Cloud, you know, is this a bucket-based storage cloud or a directory-based cloud. Dasein Cloud actually manages to abstract all that and make ones that are only bucket-based look like they're in a directory hierarchy. Obviously, not all clouds, in fact, most clouds aren't hierarchical. But when a cloud doesn't support the hierarchical storage, Dasein Cloud fakes it by creating buckets with path separators, and each path separator is specific to the underlying cloud internally, but externally it's always a dot. So if you ask for, say, a listing in Azure where the path separator is XZQ, because they don't support dots in bucket names, if you ask for root.child, you will get whatever is in the bucket root XZQ child. So externally writing an application, you don't care whether the underlying cloud supports directory hierarchies. You don't care what sort of path separator it uses. Under the covers, Dasein Cloud, for the appropriate clouds, fakes the hierarchy, and then adds on top of that an abstraction of whatever the path separator might be. So as you can see down at the bottom, the way to create a directory to create a particular directory is to specify, root.child as the notation, and true actually means if that directory already exists, owned by somebody else, to go create one. And as you may know, in a lot of clouds, the directory space or the bucket space is a flat namespace shared among all customers. So the true flag allows you to go off and have Dasein Cloud, if this name doesn't work, find a name similar to that will work. Another thing that the storage services handles is large files. So every cloud provider has a file size limit that is different from one another. Dasein Cloud has a separate API that lets you store arbitrarily large files. It will break them down into chunks and create a manifest file for reading and reassembling them. You don't need Dasein Cloud to reassemble them. You can read the manifest file and then manually put them back together. You can also pass in encryption and decryption implementations to handle encrypting on the stream rather than encrypting, downloading fully and then encrypting and decrypting. So that's really the introduction to Dasein Cloud that I wanted to get through today. Now is definitely a good time for any questions that you've been holding off on, or if anything else has come up while I've been talking.
Okay, we have a couple questions, and I would encourage people to ask more questions as we cover these. So the first one is, Matthew asked, does Enstratus use Dasein under the hood?
Yes, Enstratus is using Dasein Cloud, and that was actually the motivation of building Dasein Cloud. Is Enstratus is a cross-cloud provider, and we didn't want to have an architecture that tied us into any of the specifics of any particular cloud. So I ended up modeling the problem of cloud computing independent of Amazon rather than trying to make every other cloud look like Amazon. And then I put that into an open source library and made it available. So whenever, you'll see first Dasein Cloud will support a new cloud, and then within a few hours after that, generally, although the rollout obviously with production schedules is a little bit later than a few hours, Enstratus will eventually support that.
Okay, great. And then Kurt is asking, are cost aspects modeled in Dasein? Also, if you allocate new servers with Dasein, how do you interact with the EC2 spot market, for example? There is a weak modeling of costs in Dasein Cloud right now, and I am working on
remodeling that based on that's an area where I did something in Stratus before doing it in Dasein Cloud, because I wasn't quite sure at the time how it made sense inside Dasein Cloud. So one of the things I am working on is taking my learnings from doing the cost modeling in Stratus across multiple clouds and applying it into Dasein Cloud. So hopefully in the next couple of months we'll have a nice cost management API sitting in Dasein Cloud. But right now there's sort of a weak one where you can you can manually track your costs in a configuration file and get manually track the pricing of the underlying cloud through a configuration file and have Dasein Cloud programmatically return that to your applications. But you're having to maintain that configuration file. The other part of the question, what was the second part of the question?
It was also, if you allocate new servers with Dasein, how do you interact with the EC2 spot market, for example?
Oh, and one of the things I haven't implemented the modeling for the spot market yet, and I was planning on doing that when I did the modeling for accounting stuff or refactored the modeling for the accounting stuff in Dasein Cloud. So that's probably coming in the September timeframe.
Okay, good. And then Kurt had another question. He was asking what important provider features are not modeled currently by Dasein.
Spot Cloud is obviously, or Spot instance stuff is obviously one that's not supported. The biggest one not supported is at this instant is probably Amazon VPC. So SQS isn't supported yet, but the modeling's in there, and it'll take whoever wants to implement it for Amazon all of a couple of hours to do. But the big thing that's not supported is Amazon VPC. In most cases, I guess the other big thing would be a lot of the Azure services, and and at some level for a lot of the Azure services, we're working with Microsoft to get API access into them, and the issue is just that we don't have API access. And Azure is actually an example of collaboration between Dasein and JClouds. We're working together to implement it for JClouds, those features that are missing for JClouds first, and then we'll then provide the Dasein modeling of them once we've got that done for JClouds.
Okay, so are there any other questions for George? And George, while we're waiting to see if there are, can you, do we get complete information about this on, I'm sure you mentioned it, but can you tell us once again where we can get more information on Dasein Cloud?
Yeah, let me go back to the slide here. So it's in SourceForge. Again, it's Apache 2.0 license, so very friendly open source license, and I'd certainly welcome other contributors to the project. There's no grant. I mean, it's not some sort of corporate controlled thing. It's very much an open source, open contribution project.
Okay, excellent. So I'm not.
And I suppose I'd also add JClouds as well is under this very same model, and would also like people to help. And if you help one, you help the other. So
that's true. That's true. So everyone, feel free to jump in and help out with these if you have the time and the inclination. And George, I think that's it. I don't see that we have any other questions, so I just want to say thank you very much for a great look at Dasein Cloud, a great explanation of what it's about, and thank you everyone for joining us here today too.
Yes, thank you very much.
A few other people are typing. Okay, and I want to add that we will have the recording available very soon. We'll probably start processing it today and hope to get it out tomorrow or the next day. We have to wait for a few other people to get their parts in line. But we'll send you a link as soon as we have that ready. And I hope that you will all join us again for a webcast in the future. So thank you, everyone. I'm going to close the room out in just a moment.